Similar to your spring, you have the pendulum. The only real difference with the pendulum is the restoring force, instead of being a spring, is just gravity. And we have to sort of think about this small angle approximation. Here's our restoring force, okay? It's mostly just because we have this component, right? We have some force due to gravity that points down, but because this is a radial and tangential situation, you can break it into components that are radial and tangential, and this becomes your restoring force, okay? So when you plug this in, it gives you the same sort of differential equation, but now your omega depends on different things. So for the spring, it depended on the mass attached to the spring and the spring constant. For the pendulum, it depends on G and the length of your string. Okay, so this is the length of your string. What's G though? G is just gravity. So on Earth, this is always the same. So the length of a pendulum is really what determines its frequency. So if you want a particular frequency, if say you're building a swing, if you want a different frequency, you're going to have to change the length of the attachment of your swing to like your tree or your swing set or whatever. The only other way to change that is to take your swing to the moon or some other planet. Okay, so remember, frequency is once again independent of amplitude. Oops, I guess we did this. Okay, we're going through this again. So if we want to know the pendulum on a grandfather clock, let's say we go tick-tock, that takes about 2 seconds. All right, you plug this in, solve for L. Turns out it's about 1 meter. And if you've seen one of these clocks, they are about 1 meter. You can also calculate the period of this pendulum in the Pantheon in Paris if you put it on the moon, okay? And that's just changing your G values from 9.8 to 1.6. All right, so let's say one person swings on a swing and finds at the period of 3 seconds. A second person of equal mass joins them. Is this going to change the period of the swing? Turns out no, because does the period of a swing depend on mass? No. Okay, if it were a spring, that would be a different story. But because it's a swing, it only depends on the way the swing is constructed and whether it's on Earth or not.